Hey guys, how are you all? Hey, did you all have any questions on the homework?
No.
We saw your homework, Arya, nicely, but others, whoever needed help or anything. Okay. Uh, Arya or Dhwani, can you forward what you're doing in school?
Sure.
It would be good to know what you're doing in school nicely. For module 8, I would like to see what is in there. It's all about polynomial factoring, right? But I would like to see, can you send it now?
Yeah, I can send you the calendar.
What is it, ma?
I can send you the calendar, I think, for that.
Yeah, send it to me, ma. It'll really help.
Okay.
If you can send it to me now, it will be great.
Yeah, I'm just sending it.
Sure. Okay. And Sahil, what are you doing in school? Parvini as well.
We're doing like cubic functions and stuff on cubic functions.
Okay. So is it easy for you, the cubic functions?
Yeah, cause like we did it in class, so it's
Easy. Okay, great. Okay. You know, some of the Frisco SD kids are doing rational functions, and that puts me into a lot of distress, I feel. But since we are covering something else, right? We are doing polynomials here and they are doing rational functions. So I was asking about you. Sahil, how about you?
We're just doing like graphing like cubic functions.
Graphing?
Cubic functions.
Oh, okay, okay. How about you, Pranav? Pranav, how about you? Pranav? Oh, your mic is not working, so can you send it to me?
Miss Priya sent it to you via text.
Thanks. Text message. I really want to see.
Via what?
Yeah, I got it. I got it. January 19th, and what it is, finding complex roots of polynomial.
But we are like, I think, a
Complex.
day behind because of the snow days we had last week.
Okay, 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 okay. So you're all discussing rational root theorem and complex. Okay, okay. So rational root theorem we already did in this class, right? But I would like to review that though. Okay, graphing. Okay, which is good. Let's see. So I really want to know. 1 second, guys. Polynomial functions. See, I don't see that in here. Why? Cube root equations. Linear inequalities. Okay, anyway. 1 second, just let me. I think I'm starting a little late, but that's okay. So these joining in. Okay, let me go ahead and give you a few problems. Let's see where we are, and based on that, we'll proceed. Okay. Okay. Okay, let's see. How about this? Okay. Okay. How about this? What are the roots of this polynomial? Let's see, guys. I mean, I don't know where you are. Do you remember? Because we covered before the break, right? The rational root theorem and all we covered before the break. So let's see whether you're able to find the solution to the polynomial function. Meaning, I can rewrite it on the board. Okay. So let me share my screen. If you're not able to see, I'll rewrite it. So how about this g of x equal to x minus 6? If you're given a polynomial equation like this, right? As soon as you see this, are you able to see what degree polynomial is this? Sahil, your video is not in there. What degree polynomial is this first? What degree polynomial is this?
3.
Good. But what other details can you find?
It has a root of 6.
It has a so let's see. So it has a root of 6. Okay, and then see, this factor gives you x minus 6 is a 0. So x will be equal to 6. And then what else?
It's like an odd graph, odd and positive.
What is it, Ma?
It's like a graph which is odd and positive.
Okay, it is odd. Okay, positive because there is no leading coefficient, negative. Okay. Then what are the other roots? How will you determine that? Meaning, if you're given this polynomial equation, we should be able to say whether it has real roots or complex roots. Meaning, all the while, whatever we were discussing, right? We were always discussing things like this last week. So here, the roots are x equal to 0, multiplicity is 2. Here, x equal to 4, multiplicity 1. Do you get it? So this is what we have been discussing. But then, this is not a polynomial that can be reduced, right? So, do you all remember how to solve this? How to solve for x here? Amma, do you remember or not? It's okay if you don't remember.
You could use the quadratic formula.
Exactly. You could use the quadratic formula. This is not reducible, right? So when you solve this, x is equal to minus b plus or minus b square minus 4ac divided by 2a. Minus 2 plus or minus root of minus 4. Do you see there? It's a negative root. So what happens? It gives rise to a complex number minus 2 plus or minus 2i by 2, which is minus 1 plus or minus I. So see, what I'm coming to say is, when you're given a polynomial, the target for this class is you should be able to find out the nature of the roots. Nature of the roots means whether they are real, not real. Okay. And how many real, non-real roots are as well important. So when you look at this polynomial given, there is one real root. But this one, as you see, it is an irreducible polynomial. You cannot factor it. So it will have complex roots, meaning complex numbers will be the root of the polynomial, will be roots of the polynomial. The problem with complex roots is if you have minus 1 plus I as a root, minus 1 minus I is also a root. That means complex roots always come in pairs. Am I making sense? If you have a complex root, it always comes in pairs. Okay, so that you need to remember when we solve for complex roots. How do you detect complex roots? If they've given a polynomial like this in factored form, it's pretty easy. Meaning, if you have a complex root, there are two roots. One is the positive, one is the negative. So, you know what we call them as? What are these two called as? I think I have gone over this sometime back in this class. What are they called? So let's say minus 1 plus I and minus 1 minus I. What are they called? They have a name, right? Remember, guys? No means I have to know. That's it. Do you remember?
Conjugates.
Yep, conjugate pairs. They're called conjugate pairs. So I can always say complex roots always come in conjugate pairs. What does that mean? Suppose 1 plus I is a root, 1 minus I is a root. This is the conjugate pairs. 1 plus I is the conjugate of 1 minus I. 1 minus I is the conjugate of 1 plus I. And complex roots always come in pairs. So, on seeing this equation, its degree is 3, 1 real root, 2 complex roots. So, to this level, you should be able to write out the degree, the roots, and behavior. Am I making sense? How do you find the complex roots? Complex roots you can find using factor quadratic formula. Let's see where we are. Let's see, let me give you one or two more and then I'll know where we are. Let's see. I want to go here. Okay. Have they covered even and odd polynomials in class? Have they covered even and odd polynomials in class for Dhwani?
I think so, yeah.
Okay, how about this? If I give you this polynomial, I would like to see what is the end behavior. Let's see. How about this? Given this polynomial, what is the degree of the polynomial? What is the end behavior of the polynomial? I can help you guys. Shall I pick or you want to volunteer? Meaning, let's discuss a few more questions and then I'll give you questions to solve. Let's not be in a hurry. Go ahead. What is the degree of the polynomial? 4. End behavior? It's a 4th degree polynomial, right? So how will it be? Will it be like this? 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 How will it be? A, B, C, D. Which one is it?
E.
Which one, ma?
C.
C. So here, the leading coefficient is positive. The leading coefficient is the number that accompanies the highest degree of x. Leading coefficient is positive. So it's a 4th degree. It's like a parabola, but it will have 4 roots. So 4th degree polynomial. Okay, great. This is good. This part is good, but let's see. How about this? Okay, let me ask you this. Okay, I did not go through even or odd, right? Okay. I need to go over even or odd behavior first and then only go over some more. Hold on. We'll learn about even odd polynomials and then we'll see. How about this? Suppose, be it any function, not just polynomials. Okay, let's see. Be it any function, right? If you're given a graph like this, right? Let's go ahead. Yes, I got answers from everybody. Thanks for whoever said in the chat. So here, let's say, okay, based on graphs, even we will go ahead and study even odd functions based on graphs, right? So here, then the next topic will be even or odd functions based algebraically. One is based on graphs. From graph, how do you find it? One, algebraically, how are you going to find even or odd functions? When you look at the graph, right, when the graph is symmetric about the origin, then it is an odd function. If it is symmetric about the origin, odd function. You know how I remember? O, O. O, O means origin odd. Symmetric about y-axis means it's an even function. Any questions here? So what is this function? What type of function is this? Even or odd?
Even.
Even, because it is symmetric about the y-axis. So it's an even function. So as soon as you look into the graph, you should be able to say whether any function is an even function or odd function. Sometimes it will not be an even function. It will not be an odd function. Okay. So let's say, then you say neither. Okay. It is neither. Okay. Okay. Let's see this one. How about this? I'll give you examples of everything. Let's see the second one, guys. Second function, is it even or odd? Ma'am, please volunteer. Yes, Pranav, that's correct. Go ahead, Arya, that's correct. Siddhi, is it, can you check, Siddhi, is it symmetric about the origin or the y-axis? Siddhi, you have to open your mouth and talk, Siddhi, otherwise it's very difficult in a class. Siddhi, no, I'm not able to hear you, ma'am. Okay, so this one is when you look at this, right? See, from the origin, whatever I draw here, I can reproduce this here. You see, it's symmetric about the origin. So this is an odd function. So let me move on. Okay, this is the graphical method of finding it. Sometimes it will be neither as well. I've said, right? Sometimes it will be neither as well. I can give you a sample. So let's see this one. How about this? What do you think of this, guys? All of you. Can you let me know what is that? Anybody, guys? You shout out, guys.
Neither.
This is neither, yes. Okay. Let's see. Let me go ahead and give you a few more examples. It's a little noisy in here, so let me mute myself. How about this? Is it odd, even, or neither? Adam, Pranav, Siddhi correct. Shragvi correct. Dhwani correct. Siddhi, think about it. Siddhi, Arya, Parvini correct. Siddhi, where are we, Siddhi? Siddhi, here, do you see Siddhi? Sahil, I'm not getting answers from you. Shragvi, I'm not getting answers from you.
Are they able to hear? Sent both my answer, or
Oh,
I
you
sent.
sent. Okay, ma, I did not see. Oh, yes, Shragvi. Thank you, Shragvi. I really appreciate it. Pranav, oh yeah, you have it. Okay, so this is an odd function. So let's move on. I think this is good. So at least by looking up at the graph, you know whether it is an odd function or an even function. Okay, so now let's see this one. How to do this algebraically? Let's try this one. F of x equal to x cube plus x. F of x equal to x cube plus x. X cube plus x. Okay, now I will try to do this algebraically. This one is quite important. So what do? What I need to find out is wherever I have x, I need to substitute minus x. Wherever I have x, I need to substitute minus x. So see what I'm doing. I'll substitute minus x in here, the whole cube, plus wherever I see x, I'll substitute a minus x. Minus x. See now what happens? Minus x is a negative number basically. So that when cubed will result in negative x cubed. And then this will be a negative x. So here, what do you see? How do you compare this with this? Clearly, I see f of minus x can be written as, I take the minus out and write it out as x cubed plus x. What is this x cubed plus x? When you look at it, f of minus x equal to negative of f of x function. Who did not follow? Please raise your hand using the raise hand button. So f of x equal to negative of f of x here. When f of negative x equal to negative of f of x, the original function, this is called an odd function. Any questions? Parvini, did you understand that?
Yeah.
Okay. Arya, have they covered this in school?
I'm pretty sure.
Okay, good. Okay. So whenever the given polynomial, you're pretty sure that it is covered, you're saying, Arya?
Yeah.
Okay, okay. So whenever a function, you substitute minus x, then you get the f of minus x function. If you're able to prove that f of minus x will be equal to the negative taken out and it resembles f of x, then it is an odd function. The other cases, what is the other case? Let me write it down for you. So f of x equal to f of negative x. This case, I can say it's a even function. Sahil, are you following? f of minus x
Yeah.
will be equal to minus of f of x. Then in this case, I can say it's an odd function. We'll have to go to some complex roots as well. Let's see. Okay, so you will have to substitute that minus x and c. Okay, if you substitute that minus x, if the function just remains as is, as it was given, the f of x, then it is an even function. But if it changes to negative of the original function, then it is an odd function. Let's see about how about this one. If it doesn't follow any pattern, okay, then you can say it's neither. So how about this? Let's see this one. I just want to make sure we are there with this. How about this? How about this? G of x equal to x square plus x minus 3. G of x equal to x square plus x minus 3. You don't understand the concept. Siddhi, we are just substituting minus x instead of x. Just substitute it. Wherever you see the x, you substitute minus x. What happens to the function, you'll have to find out, Siddhi. So I substituted that, right? So when I substituted that, this c minus x, when it is square, it results in a positive x squared. This will be a minus x minus 3. This one has no pattern with this one, meaning the x square is still positive. The others are, see, this is negative, the positive change to negative, but this one is again negative, stays negative. So there's no pattern. So this is neither even nor odd. Go ahead and give you a few more. Siddhi, are you able to get it?
Yeah.
How about this? 85 f of x equal to 85 plus 20. What type of function is this? Then we need to go. One more we'll do and then we'll move on. That's right, Shragvi, Parvini, Krish. Pranav, Dwani, Adav, Arya. Sahil, I'm not seeing you on the video. Are you here or not? Sitara, I'm not getting answers from you. I understand,
I'm
Sahil, but
trying
I
to-
would, yeah, I would like to get answers from you if that's the case. If
Yeah,
you
I'm
don't
trying to
understand,
figure this one out.
sure. Yeah, that's right, Siddhi. I think you guys got it.
Can you explain to me why it's odd? I just
it is
want to
odd?
get why I just want to get a better
Sure,
understanding.
no problem at all. I will redo. The others can go ahead and do this one. Please put it as question number 2, question number 1. So, Siddhi, see here. Instead of t, I put minus t. Okay, 8 times minus t power 5 is what? A negative number to power 5 is what? Will it end with a negative number or a positive number?
Negative.
Negative number. So this becomes minus 8t power of 5 minus 2t. So compare this and this. Can I take the minus out and say this is 8t power of 5 plus 2t? This is the same as f of t. Do you see? So what I have proven? I have proven that f of minus t equal to, this f of minus t equal to minus of f, the negative of the original function. Both are the same. So, guys, was this odd or even? Was this odd or so as I said, right, f of t equal to negative f of minus t is minus of f of t, then it's an odd function. Suppose f of minus t equal to f of t, it remains the original function, then it's an even function. So as such, this is an odd function. Make sense?
Yeah.
Now let's go ahead with the last problem. Parvini, is that right, ma? I doubt, ma. Did you try f of minus x?
Yeah.
7 minus x power 6 minus 4 power 4 plus 5, right? Dhwani, is it neither? I'm getting, see, minus x, if you to power a even power, right? It becomes just even. And then minus x power 4 will end up with a x, that's all, x power 4 plus 5. So this is exactly the same as this, right, Dhwani?
Oh, I didn't look at it. Never mind.
No problem. But did you understand how it works?
Yeah, so it's even,
So
right?
it's an even function. Yeah. Now I want to go ahead and solve the roots of the polynomial that we discussed, complex roots, this root, that root, all that root, let's discuss. Okay. I'm going to give you a polynomial equation. Sahil, I'm not getting answers from you. Are you listening?
Yeah, I sent the answer.
Okay. 1 minute. Wait, then I honestly did not see. Yes, Sahil. Yes, I'm sorry. So, okay, I've given you a polynomial equation now. We are going to see. They have said, maybe this one I can do it for you if you want to. X equal to minus 3 is a factor to this polynomial. Okay, they've said that minus 3 is a root. Okay, now, then what does it mean? X is equal to minus 3 means x plus 3 is a linear factor that goes evenly into this polynomial. This is a third degree polynomial. How will you find the other two roots? We don't know the nature of the roots. We want to know the nature of two other roots. We also want to know what are the roots. How are we going to solve? Any thoughts? You can shout out.
You could do synthetic division.
Yep. Shall we go ahead and try? 5, 9, minus 13, 15. 3, 2, 1, 0, correct. So they have given minus 3 is a root. So it becomes so easy now.
It's 5 instead of 6.
Thank you, ma. So now the other polynomial is the reduced polynomial. This is cube, right? So the reduced polynomial from this one, I can write it out as this is my reduced polynomial. So the given polynomial can be written as x plus 3 times this. Now, I will wait for you to solve, guys. I really want you to solve the reduced polynomial. Tell me the nature of the roots and the roots. Can we try? If you're stuck, you have to let me know.
Miss Priya,
Mm-hmm.
can you repeat the question you just asked?
We just need to find out the roots, the other roots of this polynomial. Really, Arya? What were the roots, Arya? Whoa, Siddhi, that doesn't seem to be Arya. That doesn't seem to be somewhere. I'm missing something, guys. Arya, how did you reduce the second polynomial?
Oh,
No,
wait.
I'm asking. It's okay to go wrong, right? I'm just wondering what I am missing to explain. So you can feel free to let me know. Go ahead.
Mm. Oh, wait. I didn't check if it was real or imaginary.
Correct, Adav. Oh, good job, Dhwani. Adav, that's correct. But how do you find them, ma?
did quadratic formula.
Yep. Can you send what are they?
Yeah.
Arya, instead of trying to factor Arya where you can make a mistake, right? The best is to apply quadratic formula in these cases.
Wait, Miss Priya, if I get fractions and imaginary numbers, is it still correct?
It's still correct. Yes. Why not?
Okay.
I reset my answer.
Yes, please. Mhm. Okay, let's see. I'll check. Wait, I'm not checking. Okay. Siddhi, that is simplifiable. That root you have to simplify and say. Oh, correct. Pranav, correct. Parvini, correct. Adav, correct. Sahil, that is incorrect. Okay. Okay, let's see, guys. Shragvi, did you get ma?
Yeah, I sent you my answer.
Following it, great ma. Shragvi, we don't want the decimal ma. I would like to see it in fraction format ma. But anyway, I think it is right, but I need to see. So let's see how to factor this out. So x will be equal to minus b plus or minus b square minus 4ac by 2a minus, so this is 6 plus or minus 36 minus 100. So there is a minus 64 when you look at it. Minus 64 means it's minus. So what will happen? Minus 64 means square root of minus 1 is I. Square root of 64 is 8. So this becomes 6 plus or minus 8i by 10. So please don't send the answer like this. Okay, one root is x equal to minus 3. The other two are nature of the roots. Other two are complex roots. How will you find them? Here, please see here, you can divide by 2. Overall, you can take 2 as common. This becomes 3 plus 4i. Divide by 2 times 5. 2 and 2 gets cancelled. So the roots are x equal to 3 plus or minus 4i by 5. This is the simplified form. If you give it in this form, they will take away points. Am I with you all? Okay, let's keep going with this. How about this? Okay, one another type I would like to solve is this. Let's see. Okay, how about this? Okay, we'll deal with the second type a little later, but let me give you the roots now. If I give you the roots, you're going to go ahead and find the polynomial equation. If I give you the roots, you're going to go ahead and find out the polynomial equation. Let's see. We have done complex numbers, right? So I'm going to give you the roots. One root is 3, 2i, and root 2. So I have given you the roots now. You're going to go write the equation of the polynomial. Correct, Shagvi, I get it. Sure, Adav. Sahil, you should simplify that, Adav. You should simplify that, Sahil. So now, guys, what they have given the roots of a polynomial to be 3, 2i, and root 2. So what degree polynomial is this first? What degree polynomial is this?
5.
Hmm?
5.
5. Why should it be a 5?
Because like when you do because if these are the roots and then when you put it in the equation, you have to do x minus 3 and then x minus 2i and x plus 2i and then x minus square root of 2 and x plus square root of 2.
Good job. Go ahead now. Good job. So this is a 5th degree polynomial. So here, let's go ahead. How do you find this? See here, this is a complex root. Okay. This is not real. Okay. This one is an irrational root. Irrational means it's a real root. You see what I mean? This is a real root. Rational. You know this. Now, here we know it exists in conjugate pairs. Here as well, when you start writing the equation, so the factors would be, the linear factors would be x minus 3, x plus 2i, x minus 2i, and then x plus root 2, and x minus root 2. So the thing is, this is not the polynomial. You will have to use the FOIL method to multiply these two. You'll have to multiply these two and then multiply everything, tell me the answer. Okay, meaning, how do I do that? X minus 3. This is a plus b, a minus b formula. Do you remember? So this is a square minus b square. A square minus b square is what? 2i the whole square, right? This one is a plus b, a minus b again. A square minus b square. B square is root 2 the whole square. That becomes 2. Now, x minus 3. The thing about this is I square is a minus 1, right? X square plus 2. Then x square minus 2. When you look at this, this is again a plus b, a minus b. So you can write it out as a square minus b square and then an x minus 3. So x power of 5 minus 4x minus 3x square plus 12. This is what I am getting, guys. Arya, are you getting that?
Wait, I think I did x plus 4 instead of x minus 4. Like
Okay.
doing a math.
Makes sense. Dhwani, there was a mistake. Did you see that, Dhwani? Where was the mistake you want to know? The mistake was in here.
Yeah, I put +4 instead of -4.
It's a minus 4. So
Yeah, that's what I meant to do.
So now when you write it, you have to express it in standard form, meaning it has to come down in the powers of x, meaning you don't have an x power of 4. So it is x squared. This is how you should represent the final equation. So it should be written in standard form, means reducing power of x. Can I go ahead and give you one more problem like this? Let's see. We have not solved word problems as well. Let's see. How about this? I want to give you one more. Okay, did we do the irrational root theorem? See, for both irrational roots as well as complex roots, you'll go ahead with the positive and negative factors and then bring them in. Okay, let's see. I have discussed complex conjugates roots theorem. Okay. And then irrational root theorem also says they will occur in pairs. So here, let's see. I'll give you one more problem. How about this? Guys, I would really like you to do it properly. Send the answer to me. This will be the only problem we'll do in this type. We are going to move on. Given the roots, write a polynomial function in standard form. The roots are 2 minus 1 and then 3 minus root 2. What degree polynomial is it first?
4.
Good. So now can you go ahead?
Miss Priya, can I ask a quick question?
Absolutely, why not?
How are you able to identify the degree of the polynomial?
Okay, let's see. How do you observe the degree of the polynomial? What happens to me? Okay, so there are three roots, right, Siddhi? There are three roots given, right, Siddhi?
Yeah.
1, 2, 3. Both see complex roots as well as irrational roots come in pairs. One is these complex roots which are not real, and irrational roots which are real always come in pairs. When you think about it, what is the nature of these two roots? These are real roots and real roots that are rational. You remember real numbers we studied. In that real numbers, we had rational and irrational numbers, right? So these two belong to real rational roots, whereas this one, right? This one is an irrational root. Okay, the problem with irrational root is when one is given, you should know what is the other. Okay, when one is given, you should know what is the other. Even if it is an irrational root, it is a real root. Because you remember real numbers when we studied rational, irrational numbers inside them. Okay, other than that, there was one another system, imaginary numbers. This comes into complex. Complex roots come under this. As a result, this is real numbers. These are non-real roots. When you have complex roots, it's non-real root. When you have real roots, it can be rational and irrational. Rational does not come in pairs, but irrational and complex come in pairs. Here, it is an irrational real root, so it comes in pairs. So the factors are 2 minus 1, 3 minus root 2, 3 plus root 2. How do you solve this? The linear factors are x minus 2, x plus 1, then x minus 3 minus root 2, then x minus 3 plus root 2. Any questions? Siddhi, did you have a question how to form this from here?
No.
Okay. So the complex part about this is multiplying these two. That is why I gave you this. See, basically, but you can really take it as a minus b. Can you take it like that? Check. What are the roots? Root 3 plus root 2, root 3 minus root 2. So now, if x will be equal to this, then what is the factor? Bring everything to the side. X minus root 3 minus root 2. That is one factor. The other one is x minus root 3 plus root 2. So I have written the two linear factors here. But if you think about it, this can be considered as a minus b, a plus b. So a square minus b square. This is the best way of doing this. Here when you multiply x square minus 2x plus x minus 2. See, now I need to see this one is inside this one, x square minus x minus 2, and then you will have to multiply x square. What is the formula for this? A minus b the whole square is plus 9 minus 6x minus 2. So you need to multiply these. I will check your answers. You can go ahead and send. This is a good one actually. Whether to see whether you remember. I want to do at least 1 or 2 word problems as well. Let's see how much we can do today. Dwani, x square, x and the constant are incorrect.
I'll multiply the two.
X square and x is incorrect, Sahil. Oh, no, Sahil. Even the x cube, x square and x are incorrect. Yes, Krish, please put a message and go. Arya, no, Arya. When we are multiplying, I feel like there's a lot of mistakes.
I didn't send my answer for this one.
Oh, you didn't send.
Yeah, I'm
Okay, I'm
about to.
sorry. Okay, then that's the previous problem. I'm sorry. This is x power of 4, right? I looked through the x power of 5 problem.
Yeah, just send my new answer.
Sure. Yeah, till now we've gotten it correct. X power of 4, let's see. 7x cubed minus. Arya, the x square term is incorrect, x term is incorrect, and the sign of the constant is also incorrect. Guys, I feel like there is a lot of gap in multiplication. I'm going to do this for you anyway. Till this we have it. So let me take this, the last step, and then continue from there. I do see a lot of gaps in multiplication. So please practice before you go for any test. So here, x square minus x minus 2. Till this is correct. So this is x square minus 6x plus 7, right? If I take this, right, see, plus first, for you not to have errors, right, take x square, multiply with each. Please write it down. X power of 4 minus 6x cube plus 7x square. Then you know what I take? I take minus x, multiply with each. So that will be minus x cube plus 6x square minus 7x. Next, what I do? The third one, minus 2 I take and multiply. Minus 2x squared plus 12x minus 14. Now what I do? Can I cancel anything? I don't know if I can cancel, but I can group everything. So let me group this and this first. X power of 4. I don't want to group everything. I'm going to confuse myself. Minus 7x cubed. 7 and 6 can be combined. Plus 13x squared. Right? Now.
Miss Priya,
Yeah, ma, go ahead.
I just noticed, how did you get the plus 7? I got plus 9 for that part. Did
I hear, ma?
No, in like the second polynomial, the trinomial you have, x squared minus 6x plus 7, I got plus 9.
I can check. I can check whether we got it right.
Because like I solved it for like x equals 3 minus root 2. And that's how I saw that at that. So
This,
like,
okay, ma. Okay, to answer your question, this seems right, but I will go ahead and resolve it for you. Because you need to understand how it works. X plus 3 minus root 2. What are the, do you have?
I didn't solve it that way.
No problem, I'll show you. X will be equal to 3 minus root 2, right? The other one is x equal to 3 plus root 2, correct, ma? So the linear factors are x minus 3 plus root 2. The other one is x minus 3 minus root 2, correct, Madhvani?
Yeah.
X minus 3 plus root 2 is multiplied with x minus 3 minus root 2. See, when you look at it, I take this as a plus b, a minus b. So what is the answer? A square minus b square. So x minus 3 the whole square minus root 2 the whole square. So x square plus 9 minus 6x minus 2. Combining this, x square minus 6x plus 7. Did I answer your question, Dhvani?
Yeah.
Okay. Now when I combine this, right? Meaning don't try to mix and match everything. Let's take it slow, do it slow, because these are subjected to a lot of errors. So I have to combine these two. Let's see. I feel like I'm making some mistake. X power of 4 minus 7x cube. 13. I'm getting 11. I don't know whether it's right. And then 7 and 12 is plus 5x minus 14. I'll check. Yeah, this is correct. This is the equation. Final equation is this. I didn't see anybody who got it fully right, but that being the case, if you all understand, I'm prepared to move on. You want to solve one more, then we'll solve one more. Arya got it right, Arya?
Yeah,
Okay.
it's a
Did,
instead of plus 7, I did minus.
oh, okay. Even Pranav, you got it right, Pranav? Yeah, this is a difficult part because you're multiplying a lot of things, right? So that's why we brought in 2, 3. If you, I'll give a separate homework on this. So Please practice that multiplication. It will be very helpful. Adav, did you also got it right, Adav?
I instead of 14, I got
4.
4
Why?
somehow. I'm not sure. I'll check it and see.
You got 4. But 7 times 2 is 14. Okay, that's the only mistake. That's okay. Okay. Sahil, did you get it?
No.
Shrag? Sahil, I'm listening. Go ahead.
I don't think I multiplied it correctly.
But would you be able to do a separate homework if I give you and practice at home?
Yeah.
Okay. Okay, let's go over. I really want to do 1 or 2. These are difficult ones. Okay, let's see this one. I want to do some word problems. Word problems with polynomials. I want to do. Hold on. Okay. See, there can be several applications of polynomials for you to do. Let's see. How about this? Okay. To be very quick, right? Can you find the area of this? This is number 1 easy question. Find the area of this triangle. Find the area of this triangle. Polynomial applications, word problems, they can give you anything. We need to do some homework on that. Let's see. Can we go ahead and do this? We want more complex roots, right? Let's see. I want to do more complex roots, even odd we did, but complex roots. Yeah. I really would like to give you one problem like this where you think out of the box. Let's see. Are you able to find out the area? Okay, guys, it's just multiplication. It's an easy one, right? So basically, what do you do? I don't know whether you guys. So area of a triangle is half times you multiply the two binomials, right? I would like to get more answers. Only 2 of you have answered. So that is x plus 3, 2x minus 6. So this is what you should have done. Polynomial word problems will not be easy. We'll do one more of the complex roots and stuff. That will be hard. 2x minus 6. Now 2x square minus 6x plus 6x minus 18 divided by 2. So x square minus 9. These two get cancelled. This is your answer. That's the area. Now let's go ahead and try this one. This is an out of the box question. Okay. Is there any thoughts in this? I've given you a table here. Okay. What degree polynomial is this? It's a completely, you may not come across this in school. What degree polynomial is this? Any thoughts? But you will come across this a little later. Do you know what degree polynomial is this? How to find out, guys? Any thoughts? Any thoughts? You know what? If you want to find out the degree, if they give you that this is a polynomial, if you want to find out the degree of the polynomial, find the first difference. This is called the first difference. Okay. So what happens? 24 minus 6 is 18. 54 minus 24 is 30. 96 minus 54 is 42, right? 150 minus this is 54. 50 plus 16 is 50 plus 16 is 66. This one is 2090. So 70, 74, 78. And this one is what? 90, right? Now I'll calculate the second difference. What is the second difference? The difference between these. See? Do you see a pattern? Do you see a pattern? So when the differences become the same, the second difference is the same. So the polynomial represented by this table is a second degree polynomial. This you will come across it a little later in algebra 2. However, you need to know this, okay? This is more of a standardized test question. So when they give you a table, you start finding out the difference. If the second difference is not the same, find the third difference. Find the fourth difference. Whichever difference is the same across all, that is your degree of the polynomial. Am I making sense? We'll solve one more and then we'll take.
Wait, so it was 12 degree?
What? This is a second degree polynomial. What is? No. See, whenever the degree difference is the same, second degree was the same, right? So this is a polynomial.
Oh, okay, I see.
Represents a polynomial of degree 2.
Okay.
Okay. I want to give you one more, but I don't want to take a big one. Okay, how about this? Since you've understood the concept, I'll just show you how it works and then move on this one, the second. Okay. Sahil, are you on board? Since you're not on video, I keep asking you.
Yeah, I understand it.
Okay. Now, I've given you everything here, right? So here, when you look at it, right, for this one, the difference, how do you find out the difference? Finding the difference is also sometimes tricky, okay? As soon as you're given the problem, you will yourself get confused. Oh, do I subtract minus 10 minus 6, or how is that I'm going to do? It's always minus 6, the successive term, minus the previous term. That gives you 4. 8 minus 6 is 14. 44 minus 8 is 36. So here, do you see? The third difference is the same. It need not be always 12. It's coincidentally 12. Okay. So this table represents a third degree polynomial. Make sense, guys? Shragvi, does it make sense?
Yeah.
Really appreciate your dedication, Shragvi. You're attending from elsewhere, right? Mom told you and you attended. Very nice. Okay. And then let's see about this one. Okay, how about this? These are test-based questions, guys. Okay, you're all going to go to AP Pre-Calc next year, and then you're going to write a standardized test. So you should know all these. A polynomial function has 3 real zeros, 4 non-real zeros. One of the real zeros has a multiplicity of 6. What is the degree of the polynomial? I feel like the answers are incorrect. So what is the answer here? How many zeros are in here? 3 real zeros, 4 non-real zeros. Yeah. See, guys. No, I think you forgot. Wait. We'll go with an example first. Everybody's making mistakes. So see this one. How many roots are in here in this polynomial? How many roots are in this polynomial?
3.
3. This is one real root, which is 0, but the multiplicity is 2. Right? This is one real root, multiplicity is 1. So the multiplicity does change the degree. Do you see it?
Miss Priya,
Yeah, go ahead.
how did you know that the multiplicity was 2?
The degree, that's what we discussed last week, right?
Oh yeah.
Because no problem if you don't remember. See, x equal to 0, the multiplicity is 2 means it is a repeated root. It is a turning point, you see? It'll go like this or like this at that point. So the graph for this, 1, 2, 3, 4. There is one root here, one root here. Okay, it's a cubic one, right? Cubic one means the graph end behavior is like this. So the graph will be like this. You see what I mean? Meaning this will go like this, meaning at this point 0, it will take a U-turn because of the degree 2. Then it will come down. You got it?
Yeah.
So here it has 3 real zeros, means 2 real 0, each with multiplicity 1. That 1 real 0 is a multiplicity of 6. So there are 6 roots. Here there are 2 roots. 4 non-real zeros means they might be in conjugate pairs. We don't know. 4, they will always be even, non-real zeros. So there is 4. So how many roots in total? 12 roots. It's a polynomial of degree 12. Am I making sense? Okay. Okay, guys. If you have questions, just let me know. Otherwise, we will see you next class. Shall we wrap up here? I'll give proper homework, but I'll post it tomorrow, guys. Okay. Any questions for me?
No.
Nice.
Thank you. Bye.
Bye.
Okay, ma. Bye, ma. Have a nice evening. If you have a question, stay.
Okay.
Sitara, did you have a question for me? Sitara?